All right, so here we are in BC2 Part 2, measuring angles. And this time you're going to need a protractor. If you don't have a protractor, you can do this in class when you come back to class. All right, so we're just going to kind of discuss all aspects of angles, what they are, how to measure them, how to draw them, and congruent angles, bisecting angles, so all those different features. So we'll just start off with what is an angle. And hopefully you recognize by now that you see that an angle is actually made up of two rays that intersect at one common point. So that's what we're going to say, that an angle is a figure formed by two rays with the same endpoint. And the rays end up being the sides of the angle. And we have two sides. We have BC and we have BA. And the angle opens up in this direction. So it gets larger that way. And so BC, or ray BC, is what we call the initial side. And then ray BA is what we call the terminal side, where it ends. Okay, and the common endpoint is B. But we give that a name as well, and we call that the vertex. Okay, so there's all the terminology associated with an angle. When we name an angle, you kind of have three options. So angles are named in three different ways. And it's usually depending on what information is given to you. And in this diagram, all the information is there, so we can name it in three ways. You can name it using the point. So you can use three capital letters. Okay, and so in this case, it doesn't matter where you start. It just matters that the vertex is in the middle. So we're going to write that we have angle ABC. So the middle letter must be the vertex. It's okay if you named it angle CBA, that's the same angle. Well, since this angle wouldn't be confused with another one that's maybe attached to B or has the same endpoint or vertex as B, we can just use one capital letter, B, and we can just say it's angle B. And then this angle has its own name inside, and it's angle 1, so we can use one number. And we can just say it's angle 1. Now this part you're probably familiar with, that there's 5 types. 4 of them you probably are familiar with. This 5th one, a reflex angle, might be new to you. But we'll just write a real short definition and a diagram for each one. And we'll just say that an acute angle is an angle that measures less than 90 degrees. Right, so you can just draw any angle with an initial side, a terminal side that is less than 90 degrees. Let's just say that's 40. Okay, so there's an acute angle. A right angle is an angle that measures exactly 90 degrees. Right, so again, we have our initial side, our terminal side, and now we can label it with this box that indicates that that's a 90-degree angle. Okay, and you probably know this, or you might be seeing a pattern. Now we're going to say that an obtuse angle is an angle that measures, this one's a little longer, it's the longest one, measures greater than 90 but less than 180. Okay, so we draw our initial side, we go past 90 degrees, and I'm just going to say that's a 120-degree angle. So it's more than 90, but less than 180. A straight, that one's kind of in the name. It's an angle that measures exactly 180 degrees or makes a straight line. right, so you can say here's your initial side, and it opens up to make 180 degrees. And then our last one, a reflex angle, is an angle that measures greater than 180. Okay, so I'll start with the initial side and a vertex, and it's going to open up past 180 degrees. Okay, and I don't know, maybe that's 210 degrees. All right, page 4. So we're going to measure an angle, and in this page you're going to need a protractor if you have one, but you can still follow along. We say that the angle symbols, these are the 3 common symbols. They all refer to the actual physical angle. So angle ABC means, we're going to write it, angle ABC. So you're referring to the actual angle itself. If there's an M in front of that angle notation, that means we're referring to the measure of the angle. So this notation means the measure of angle ABC. Okay, so you need to know how to use a protractor, and there's a task on Khan Academy where you are going to use a protractor online, and it's going to, set up the same way. Just what you need to do, if we're going to measure angle VDS, you're going to put this open circle on the vertex, which is the middle letter, so that's D. Okay, this line that comes off horizontally from the circle, that's going to line up with your initial side. And then you just follow along to see where does your terminal side meet up with the protractor. So notice we're starting from 0 degrees. So we're following the inside track. Oops. Okay, so angle VDS looks like it's, there's 140, there's 145. So maybe it looks like 148. So if it's 148 degrees, that makes it obtuse. Okay, SDL. So now we're dealing with an acute angle. Same thing, put the circle there at the vertex, line this line up on your initial side. Now, you might not like the idea that we're like, well, where does that meet up? Maybe it's at 15 degrees or maybe it's 16 degrees. Well, what you can do is you can extend your terminal side. Right, so if the terminal side isn't long enough, just extend it. And now you can see that we're right there on the 15 degree mark. Okay, so SDL is 15 degrees, that's acute. IDS, well, I think you can see where this one's going. Right, so here's our initial side. We look where our terminal side is going to intersect with the protractor, and that's at 90 degrees. So that's a right angle. And then the last one, SDE. SDE. Okay, well, and you can see that that's obviously a straight line when you line this up on the protractor. The terminal side, or the initial side and the terminal side are both on the line. So that's 180. And that's straight. All right. To draw an angle, again, we're going to need a protractor. This time we're going to draw a 115 degree angle. And you're just going to start with an initial side. And that really can start anywhere. You can say, all right, there's my initial side. There's my vertex. And you can even put your vertex anywhere on that line. Doesn't really matter. Okay, we're going to line it up. Notice how the 0 is on our inside track. So we're going to follow that until we get to 115 degrees. We're going to put a little mark there, and this time it's off into the black. Okay, then just line up your vertex with that mark you made and draw your terminal side, and now you have a 115-degree angle. Okay, we're going to draw an acute angle. Okay, so there is our, sorry if that was all over the place. There's our initial side. Lay your protractor on that initial side. Find your 25-degree mark. And draw your terminal side. Okay, so that's an acute angle. All right, so important things to note is that the units of an angle are called degrees. And the symbol, we use that little superscript, that little circle there. And when we write that what a measure of an angle is, you write it like this. The measure of angle 1 is 68 degrees. All right. Last 2 pages. Congruent angles. Like congruent segments, they require markings for you to know that they're congruent. So 2 congruent angles, or 2 angles are congruent if they have the same measure. So here I have 2 trapezoids or 2 quadrilaterals. Use the given congruent statement. This is a statement that says these 2 shapes are congruent to correctly label the diagram. Well, what this tells you is that A and W are congruent angles. So we'll label this trapezoid A, B, C, D. Follow the same order, because this one says A and W are congruent, B and X are congruent. So this one's going to go in that same order, W, X, Y, Z. And A is congruent to W. So what we're going to do is we're going to write, instead of a hash mark, we're going to write an arc with a single hash mark in it. Well, now we know B and X are congruent, but they're different angles, different measures, so we make an arc. But this time we put 2 hash marks in it. So now we know that those 2 angles are congruent. Then we just follow that pattern. C and Y are congruent, so make an arc. And then we put 3 hash marks in it. Now we know that those are the 2 congruent angles. And then lastly, D and Z, and we could put 4. Obviously, if you get more than 4, it starts to get a little scrunched up, but I don't think you're going to see that too often. Okay, so just an important clarification. If you say that the measure of, let's say, angle ABC is equal to the measure of WXY, that also means that angle ABC is congruent to angle WXY. So like segments, we can say that the measures are equal, but the actual physical diagrams or the physical shapes are congruent. Okay, angle bisector, again, this is kind of mirrors the segment lesson. We have segment bisectors, we have angle bisectors. And we're going to say that an angle bisector is a ray. It starts but never ends. That divides an angle into 2 congruent angles. Okay, so we're just going to draw a diagram that meets this description. Ray BD is an angle bisector of angle ABC. So we'll draw angle ABC. And BD is our ray that divides the angle into 2 congruent parts. That means it goes right through the vertex. Okay. Now, right now, it just says this ray is in between or on the interior of that angle. We have to put the arcs to show that they're congruent. And since we don't have to label any other angles, we don't need to put the hash marks in there. All right. The angle addition postulate. Again, like the segment addition, the parts add up to the whole. So the angle addition postulate states that if B is on the inside of the angle, then the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. And I probably shouldn't have the diagram first to start, but you'll see it here in a moment. But this is a part plus part equals whole diagram. Right, so this is the original angle. Angle AOC. And then B is on the interior. So it doesn't matter where B is. It's just a point on the interior. Okay, so now all we're saying is this part plus this part is equal to the whole angle. So in other words, the measure of the larger angle, that's angle AOC, is the sum of the measures of the two smaller ones. All right, so I will do this example, you will do that example, and you'll show me this when you come to class. All right, so this just says, if the measure of angle 1 is 95 degrees and the measure of angle ABC is 136, find what's left, find the measure of angle 2. We'll label what you have. This is 95. This whole thing is 136 degrees, and we're looking for angle 2. So now we can write our part plus part equals whole. The measure of angle 2 plus angle 1 is equal to the whole. Right? So we subtract 95 from both sides. The measure of angle 2 is equal to, and what's 136 minus 95? I don't know, 136 minus 100 is 36, so this must be 41. Okay, 41. All right. So you do this one, and then we'll go over it in class.